Let's talk about visualization. Visualization is an important part of business intelligence. So far, we already see how we want to store data in a data warehouse and how do we move data inside. Once data is inside the data warehouse or lakehouse, the goal is to derive a meaningful analysis out of it. And in previous sections, we talked about the overall process of business intelligence or data analysis, right? It starts with the dashboard, summarize the data with some visualization. Then we have the static, standard, or operational report, whatever you call it. Then from the detail level of a static and standard report, we can further discover issues, perform some ad hoc reporting and online analytical processing or OLAP as it's called. Based on cube or based on databases, we perform some calculation, aggregation, comparison, contrasting, and this is what we do for data analysis. Then from the result of the analysis, we do forecasting, we do planning, we do apply certain actions. This usually is done by some data scientist. You will predict the potential, you will analyze what may be the course, what may be the cure to the issue, and once you apply the cure, what's the result? 20% of chance you will do this will happen, 80% of chance this will happen, etc., etc. Then eventually you can also apply some machine learning and artificial intelligence. We even use we can use TikTok as an example, like how is TikTok identify your interest and try to glue you to your cell phone screen as long as possible. With that, you can clearly see that dashboard is the beginning of the whole journey, and the rest, static reporting, ad hoc reporting, analysis, all requires a special attention. But the starting point is definitely dashboard, which mostly consists of a data visualization. Um, why would the visualization important? Why do you need to visualize data, right? So the question example, a starting question would be, what can these two numbers tell you? What can you get from these two numbers, 3 and 6? And if you think about it, this doesn't really tell you anything, right? If you are confused and you're lost and are not sure what you should say, you are right. This 3 and 6 does not tell you anything because they come here without any context. However, if I draw these two dots, 3 feet and 6 feet to the wall, and I put the two human-like shapes here, it immediately gives you a context that you are measuring someone's height, and these two someone is standing next to each other, one taller, one shorter, and you can immediately come up with context. Even will imagine maybe this is a father and son, right? This is the visualization. This is what the visualization can do. It can immediately, using visual elements, to provide you with a context of a certain data. Similarly, if I give you this, looking at this, given what you see, you have 2014, 2016, 2018, 2020. This immediately provides you with some assumptions and the context. Most people, by looking at this, will assume it's the growth of some data across these years, although I never say these are years. I didn't mark year here. I put a feet here, but I didn't put a year here. But by looking at these dots, you will automatically assume this is the time series, right? Most people will make this assumption. There's a time series, and there is something trending. So this is what we call storytelling. By utilizing certain visual elements, you are telling people a story, and by telling this story, you are forming by visualizing this data, you are providing people with a context. And by providing the context, you are doing a storytelling. You are telling a story. This is all visualization is about. Right? The visualization is about storytelling, but of course there are good visualizations and bad visualizations, just like there are good stories and bad stories. The same picture across a few years, I can also visualize like this. But what will this visualization tell you? I think nothing but confusion, right? So this this session is about how you should do your visualization and how you should avoid in creating visualizations. We will start this analysis by scatter dot, and in fact, all visualization should start from scatter dots. Scatter dot is as simple as you, for each instance, for each data tuple or row, whatever you call it, draw a dot in a two-dimensional picture. In this two-dimensional picture, you draw a dot for each instance you have. In a relational database or a relational data set, there will be one row. In a JSON document, it will be in the document oriented store, it will be one JSON document. Whatever it is, it's a representation of one element, one instance in real world, and you are drawing the dot based on some characteristics, some statistical values of that dot, of that instance on this chart. And scatter dot, it should be used first for discovering the pattern. A lot of times, a mistake made by newcomers is that whenever they think about visualization, they think about drawing fancy pictures. Now, visualization has some room for fancy pictures or fancy trend lines. But most importantly, visualization is about story and about trend analysis, pattern discovery. Do not make assumptions before you go into a visualization. If you are thinking I will use a pie chart or you use a bar chart, before you ever utilizing scatter dot, you're already making assumptions about a data set. That that assumption may be correct, but it may also be incorrect. So try to avoid that by not assuming any visual characteristics. Use scatter dot to begin with to discover pattern. Now for this chart, there is a clear pattern, right? Clear relationship between this diameter and height. However, it's not always so apparent. For example, the famous iris dataset. If you don't know what iris dataset is, iris is a species of flowers. And under this iris flower, there are multiple species. A famous statistician, Dr. Fisher, picked the three iris species and measured the size of a flower for 150 flowers. That 150 flowers belongs to three species. Each species has 50 data, have 50 flower instance. He measured that and published that about 100 years ago. So this iris dataset is a famous dataset in statistics and has been widely thoroughly studied. Now, looking at this, if I use the sepal width and the sepal length, but sepal is a part of the flower. So sepal width and sepal length is a part of a measurement. It's two characteristics of that measurement, two features of that measurement. If I use the sepal length, width and sepal length as the x and y axle, I'm guiding these dots. Looks like there are some groupings, right? It looks like there are some grouping. Remember, we have three data sets. But is this really a grouping, or is that should be something like this? It's hard to tell. So we need to add more visual characteristics into a visualization, in addition to the scatter dot that we have. So these are some most common characteristics that the people use: color, size, position, shape, background, placement, etc. There are much more, but for time's sake, we are only going to talk about these most important ones. So starting with position, right? When you do a scatter dot, and you're placing those dots in a two-dimensional chart, you need to choose your XY axle carefully. You need to make sure they can show up and can represent something that really tell a story. Like here, this is the magic corner from Gartner for cloud infrastructure and platform services, which is what we are starting for the first half of this course. So here you can clearly see Amazon Web Services, even without knowing what these are. You can see Amazon is leading the crowd by a comfort margin. But on the other hand, for this measurement, Microsoft is not as bad, is almost as good as Amazon, actually slightly better. And overall, Google is somewhat behind the leading two. So by looking at this, although you may not know exactly what Amazon is better or in completeness, you can tell that Microsoft probably is the best in completeness, and Amazon probably have the best ability. But these both of them have a good completeness, and Google is short in both, and the rest are like somewhere trying to catch up. So this is the position. By placing the position, by placing the scatter dots properly, you can you can give people an immediate impression of who's leading and who's behind. Now, the most common characteristics actually, in addition to placement, to position, is the color. So if I mark the iris dataset with a color, each color represents one series, one species of flower. What do I get? I immediately see the red flowers has its own characteristic, whereas the blue flowers are slightly larger, are somehow larger, but not very distinctive from the green flowers, right? So you use color to group dots to tell patterns inside the pattern. Inside this complex pattern, you use the color to separate the groups out so that you can see inside each group, each subgroup, there are further patterns for you to discover. The other way of doing this is by defining a size, and this one is unfortunately a burglary rate and a murder rate. But we are arranging the we are arranging the data sets by criminal rates. And in order to identify, there is definitely a question: is that somehow related to the size of the state? Would that happens if a larger state have more crimes or larger state have less crimes? Either way is possible, right? So we add the size based on the population of the state. But as you can see from here, it's immediately telling you a story. What story is that? Does size deliver any information here? It looks like size doesn't matter. California, like smaller states, may have higher criminal rates, but the smaller state can also offer less rates. At least from this chart, it is very hard to tell whether size matters or not. And looks like it likely is not, because the largest states are somewhere in the middle. That means it probably doesn't matter. So size may offer information here that it doesn't matter, but that the population doesn't matter. But it may also offer, but if you cannot for sure tell, maybe it's a good idea to remove size away from this chart. Anyway, it serves the purpose of identifying a character that can be utilized, and the conclusion may very likely be it's not relevant. However, that the not relevant could also be a conclusion, right? So it depending on how what information you want to get from this chart. Now, size and color can be combined together, and I intentionally choose this Chinese map here. This is a map, a Chinese map. I choose Chinese because nobody knows the words, so it's you have to use your imagination and the common sense to read through this. What are these blue things? I give you 3 seconds to think. What are these blue things? Right? I think most people, although these are like Chinese characters, you can imagine these are sea and the lake and the river. And what about the dots? By knowing this, that this is a landmass, I think you can correctly guess these dots are cities. And these cities have different color. Some have a red color, others are blue, and some of them are, I think there's no the black ones, but then they have different sizes. This one apparently is larger than this one, and this one is still larger than this one, right? So what does this size mean? I believe most people can guess. Given the dots are given the dots are cities, the red ones probably are more important, and the smaller one, the smaller the dots, the smaller size, the less population it have, right? Which is exactly what this map is trying to tell you. With that, so many different options, right? We talked about X, Y position, we talked about color, we talked about size and the combination of both. How do you choose the characteristics? How do you choose which one to use? And how do you choose which one is XXO and which one is YXO? You have to choose that based on your experience. For example, for the iris data set, this is the original one we choose, right? But then if you switch over to use this pedal length and the pedal width, instead of the original one, we choose sepal length and the sepal width. If you choose pedal length and pedal width, which is another part of the flower, it's more representative. You can see the flowers, the red flowers are here, green flowers and blue flowers are closely adjacent with each other, but they are they are very distinguished. They are separable. But that's because this iris data set is a small data set, 150 data points, and has been there for 100 years, has been studied over and over. So that's when we can do a complete combination of different options and identify the best one. For data set that you do not know, you have to use some kind of best educated guess and some common sense, then also some trial and error. If you utilize one, maybe you want to try take a best guess, try that visualization. It doesn't work, then try to find another one. That's a part of your exploration into the data. It helps you to identify what's the key characters that can separate data, can identify each instance. With that, there's also some enhancement to scatter dots, right? We so far we have been talking about scatter dot. Everything is a scatter dot, but sometimes there are ways to enhance scatter dot to make a scatter dot more vivid. So common characteristic you use, you want to turn dots into shapes instead of dot, because dot is in people's mind is probably less important. Each individual dot are not as important as a large shape. So you want to turn dots into shapes to make it more significant, to emphasize the importance. Scatter dots can show patterns, and pattern can be further visualized, enhanced using shapes like line, bar, and pie. Let's start with bar chart. When I first put these two dots on a chart, on a wall, and put the feet here, it's telling you there's some kind of a height marking. But what does this height marking mean? Once I put two human-like figure here, it gives you a clear indication, like from this button to here, that's the height of one person, and from here to here, that's the height of another person. And when you compare and contrast, you clearly see the difference. One is probably an adult, another is a child. That's exactly what bar chart is used for. It's utilizing a bar to signify the distance, the size, the amount, the volume of that chart from 0 to that dot. So if you look at this chart here, right, this 24, 78, in fact, what really it is a yellow dot here at 24 and a blue dot here at 78, then a yellow dot here at 44, a blue dot here at 24. By adding a solid rectangle here, you make this 24 and 78 much visible and signifying the difference between them, right? So this is when you use bar chart. You use bar chart to signify to comparing numbers for discrete number of groups and subgroups. This is one group, this is a subgroup. You compare these two subgroups. Apparently, this subgroup have more data, have higher index values than this one, and this one is less than this one, right? So these are the um, bar chart that you can use for discrete number comparison of discrete number of groups. If you have several groups of data, you want to compare them, show the difference, show one is better than the other. That's what you use bar chart. Now, bar chart does not necessarily need to just be solid rectangle. It can be anything. It can be human-like. If you think about this one is actually a bar chart, right? But I'm not using a solid rectangle. Instead, I use two human pictures. And here to the right is I get this from a news reporting of two countries' military power. And as you can see here, maybe you cannot see it clearly, but these are human look, soldier look charts. And by comparing the size of the army and comparing the size of tanks, right? Each 1,000 tank, 1, 2, 3, 4. These are the tanks, and here is the Air Force airplane shape, representing like 200 airplanes. So this is not bar either, but it serves the same purpose of utilizing certain visual marks to show to signify the scattered dot's position, signify the value that represented by that scattered dot. And it's used to compare, just like what we say, compare two discrete groups of values. Followed by the bar chart followed by line chart. What do you do with the line chart? When you have a bunch of scattered dots, you can, and these dots are continuous, which means each dot is somehow related to the dots behind it, ahead of it, or behind it. In this case, if they are related, you can use lines to connect different dots one by one. If you have enough dots, it will give you a curve, which is a line chart. Because line chart basically is a connection between different dots, that means you want to use that to show a continuous trend. You usually use this for continuous series, especially time series. What something changed over time, that's bestly used by line chart. And on top of that, you can also put a trend line, which is the statistic prediction of what this line chart is actually about. You can use this to indicate statistic characteristics or even show predictions. That's a 0, 15, 30, 45, 60. If I have one more 75 here and probably a 90 beyond this chart, and I have a chance going beyond this, I can certainly predict what this dollar amount may be at point 72 or 77 or 85, right? This is the explanation calculation based is one of a numerical uh, analysis technique. So trend line, but note that one thing we usually do, trend line you use dash lines because they are not something really happen. They are something that exists in your mind. So make sure you use the dashed line. Then we comes to pie chart. Pie chart is used pretty often. It's used widely for percentage. It gives you a quick glance of the percentage or portions of different groupings. But remember, pie chart can be very limited. That's because human eyes are not good in telling the difference between angles and areas. In this case, of course, this one apparently is the largest, and this one is also the largest. But what about something like this and this? And so they are pretty close, 588, 428. You can see somehow that this one is larger, but not exactly to the extent that you want to, you can be able to tell what's the difference, right? And if you have really close ones, make sure you make, pie chart is not good in telling what's the difference. If you really want to compare these two, you probably want to draw a bar chart so that people can see 588 is significant is clearly higher than 428. So bar chart you should only use it when the story is simple, and usually this is at the beginning of story. You are just showing a portion. You are showing some trend, showing some percentage. Which one is most important? Which one is give you the least amount of a profit or cost or revenue? This is what you want to use it for. And you need to really avoid using pie chart everywhere. Avoid using pie charts, first of all, when there are a large number of groups, and these two are actually closely related. When you have a large number of groups, there will be a number of groups with smaller percentages, right? Like here. Would your reader be would your reader care about these tiny little groups? Apparently, the answer is no. So you either use an overall category or create a top 5 or top 7 um, pie chart to show the usage, to show the percentage. So here the story, what's the story? Is that a lot of small groups, or is that this one is the most important? In this case, you probably want to draw a bar chart, which tells more story. And then there's common background. Most common background is the map, but here there is the mindset paradigm that you need to shift. We are trained to look at these lines as a part of a map, as a part of geography. But in fact, these lines and the state name, Texas, Oklahoma, and Kansas, and Nebraska, these are not part of geography. They are labels. They are human-created labels on certain point of a geographical area. So what this picture is, if you do not look at those labels and lines, what it does is a U.S. map with scattered dot. This scattered dot marks the temperature in each point. Let's say we have in New York. Where is New York? I think it's here. In New York, there is a temperature. There's a weather station which record the temperature. Then in Miami, there's also a temperature station which record their temperature. When we put all these scattered dots, so these are fundamentally still scattered dots, and I mark them with longitude and latitude as a position, and mark them with color to show the temperature. When I have enough scattered dot, that's when I get this representation. Now, if I add a background of a map of these labels, I can clearly see the difference between different states, right? So you are applying, what you are doing here is you're applying these lines, this state border lines and the state name labels on a scattered dot plot based on longitude and latitude. Why this is important? Because a lot of if you want to create more vivid or more nice looking uh, visualization, sometimes you need to think about out of box. And this map is actually a big box that many people cannot break them out of. Because you have this state mapping, but you can also have other things. A lot of things can be drawn based on this longitude and latitude scattered plot. I myself is not an artist, but I do see people drawing creative ones outside. So this is just a friendly reminder that this is something that you can do. And now let's talk about compare and contrast. Compare and contrast of different visual enhancements and the visualization characters. So it starts with a compare and contrast. You will try to use the same scale, background, but different visualization characteristics to show the difference of similarity. The For example, bar chart, we already mentioned that. Bar chart is very good for contrast of discrete groups and subgroupings. Even remember the previous pie chart. It can, if you put them in order, you can clearly see one of the group is better than the other, have a more percentage than a more higher value than other, and then other. You can clearly see a decline and identify the group, and that one will give you a clear understanding of the numbers and comparisons instead of putting everything into a pie chart. If this comparison is what you want to show, then here is the compare contrast. Sometimes you can just compare and show the similarities. In that case, make sure it's really a similarity. Like here, it looks like a similar, right? But I saw people like have two lines that largely resemble each other, but at the end have a significant difference. So that will make people confused. What the story are you trying to tell? Are you trying to tell these two are similar? Are you trying to tell these two at the end will be different? You need to organize your story so your message is clearly defined. If you are trying to, if you are trying to put the two set of data together, make sure you are clear yourself what you are trying to show. Are you trying to show they are similar, or are you trying to show they are different? And then present accordingly. And sometimes you don't need to even have the same amount of same type of visualization. You can have a heterogeneous chart. This is just another example of the background. And in this case, which one is more important? Give it a bold color so people can see it clearly. That will be the first thing coming into their mind. Then the background, which is used for comparing or for some providing additional information, use a light color or even blank.